In this video, we are going to be learning some background information about computer programming, and we'll be writing our very first programs in C++. In particular, we'll be learning how to print things out to a console window. So let's go ahead and get started. The very first thing we need to do in order to write our code is launch Visual Studio, which is an example of an IDE. Now, IDE stands for Integrated Development Environment, and this is a piece of software or an application that's going to help us to write computer code. So let's go ahead and launch Visual Studio. For me, I'm going to do that by clicking on this Start menu. I'm just going to search for Visual Studio 2022, and I'm going to go ahead and launch that. Once Visual Studio opens, you'll see that this menu pops up, and what I want to do is create a new project. And the type of project that I would like to open, I've got to scroll down a little bit, is an empty project for C++. So I'm going to go ahead and click Next here. And it's going to ask me to name my project. You can name it whatever you'd like. We're going to be dealing with writing out to the console window. So I'm just going to name my project Console Window. And go ahead and click Create. Now, once this project has been created, what I want to do is go over here to Source Files on the right, and I'm going to right-click, and I'm going to add a new item, which I'm going to call main.cpp. And I'm going to go ahead and add that. You don't have to name it main, but there's reasons that I name it main. And what we're going to start with is the basic shell of a program that we always need to write in order to have meaningful C++ code. For the time being, we're just going to accept this as our basic template and use it all the time. But as time progresses, we'll start to understand what the individual pieces do. So let me go ahead and type out that basic shell of a program. And here it is. What I've got on the screen right now is a basic program, the minimum that we really need in order to compile our code. Now, what I mean by compile our code is to go right up here and push this little green button that looks like a play button. It says Start Without Debugging when I hover over it. And if I click on that play button, my code will compile. And this console window will pop up, and it will do what the code tells it to do. Now, really, what that means is it will do nothing at this point because we haven't told the computer to do anything. We've just created this basic shell of background information that we need in order for this console window to just even pop up. So this is called the console window. It doesn't really do anything. You can see that it wants me to press any key to close the window, so I can do that. And let's return to that statement of compile, the little green button. What it means to compile code is to take what we've written here and translate it into instructions that the computer can understand, which is translating from our high-level programming language of C++ into something called machine language the computer can understand. One of the things you should notice is that the IDE does helpful things for us. This IDE is meant to help us write programming languages. One thing it does is it numbers the lines of our code so we can see how much code we've written and what portion of code appears on which line. The other thing you'll notice is that it color codes the words for us, and those colors all have a meaning that are supposed to be helpful to us as programmers. One of the things you'll see is something like this color here is blue on int and using namespace. One thing that's being indicated to us by that blue is that that word is a C++ reserved word. C++ is this language that only has something like 95 words that it understands. And one thing that's being conveyed to us with this color coding is whether or not a word is a reserved word. So that's one of the things that's being used here in the colors. There are other meanings to the various colors, and the colors that appear on your screen might not be the same as the colors that are appearing on my screen, depending on the mode you've selected for Visual Studio. I'm using dark mode, but you should have a coloring scheme that's visible to you. So the line numbering and the color coding are examples of features of the IDE that are meant to be helpful to us as programmers. So as I said, this is the basic shell that we need to run every program. We'll start to understand the pieces of it more as we progress throughout the course, but for now, just know that you need all of these things in order to make this program compile. Now, it wasn't a very interesting program. When we compiled it, it didn't do anything. So let's see an example of giving a command to the computer that it can follow so that we can see our code actually create something in that console window. So the first line that I'm going to add to this code comes before the return 0 statement inside those braces. I'm going to type COUT, pronounced C out, then 2 less than symbols, followed by quotations that start and stop, and I'm going to type hello world. I'm going to end this line with a semicolon, and if I go ahead and compile this code, we should now see something in the console window, which is the exact phrase, hello world. So the Hello World program is meant to be any programmer's first real program where it looks as though the computer is talking to us and saying hello. So let's go back and talk about what's happening in this program in more detail. So the first is the word cout. Cout means print out to the console. So console out is what cout stands for. You'll notice the word cout does not appear in blue, meaning this word cout is a command that we are giving in the C++ programming language to the computer, but it is not a reserve word. It doesn't have the right color. So this actually brings us to our first bit of understanding about what's going on in the shell of our program. C++ is a programming language with only 95 reserve words. Other programming languages have different numbers of reserve words, but they're always very few. Frequently, we need to use more than just the 95 words that are allotted to us, but C++ is not built in to have understanding of those words. The way around this is to include a library book of sorts of reference where we provide the definition of that word, since C++ does not know it automatically. So the word cout is not a reserve word in C++. It's a word that is defined somewhere in a file that the computer can go read and learn the definition of. So there should be some line of code in our basic shell that's telling the computer where to go look up the definition of the word cout. And that's coming from this very first line of code in our basic shell, this pound include IOStream. My favorite bit of trivia about this pound sign, which is what I'm referencing, you might call it a hashtag. It's actually called an octothorpe. That's just a little bit of trivia for you. What this pound include IOStream line of code is doing is it's telling the computer that before it runs its program, it should include the file IOStream. And IOStream stands for input-output stream. So C++ only knows 95 words. There's all kinds of other words we might want it to know, but we don't want it to know them by default to carry around all these definitions at once. So what we're doing is including the IOStream file, or library is the word we use, and that's meant to be suggestive of the process that's happening here. We want to include this particular book that exists in the library, the IOStream book. IOStream is like the title of the book. It's telling us the types of words that might be defined in that book, things that have to do with the input and output stream of that console window. And so this very first line of code that we have here is telling us that before we can actually run our code, we're going to need to go look up some additional words that have to do with the input-output stream. So that's one of the things that's happening with this basic shell, is we need this line of code on line 1 in order to understand this word cout, which is not a C++ reserve word. Now next we have these two little less than signs. they're coming after the word cout to say, well, what do we want to print out to the console screen? These two little less than signs together are what we would call an extraction operator. And it's what comes after those two little less than signs that we want printed to the console. Now you'll notice a few more things. The first of which is that we have these quotation marks surrounding the phrase hello world, and we have this semicolon. And if you were looking carefully at what we compiled and what showed up in the console window, you'll notice that hello world with the exclamation point appears in the console window, but these quotation marks and the semicolon do not. So the quotation marks and the semicolon are also having a special meaning to our program, and they're not literally what's appearing in the console window. So we can think of the quotation marks as going along with this console out statement, the cout statement. We need to tell the computer what we would like printed out to the console. We're going to use the quotation marks again, as we would sort of in speech and in dialogue. The quotation marks are there to indicate the starting and stopping point of what we want printed to the console. And it's what's between these quotation marks that will be printed to the screen. The quotation marks themselves will not be printed. They are there to encapsulate what it is we want printed to the console. So last but not least, we have the semicolon. And the semicolon is acting much like punctuation in physical writing. It is saying that we are done with this command that we've given to the computer. And so it's acting like the period at the end of a programming sentence. And you'll see these semicolons actually in 3 places in our code: after the using namespace std, after, at the end of line 7, and at the end of line 8. So each one of these semicolons is the end of a line of code in programming. It is like the period at the end of a sentence. It is always needed in order for the computer to know that we're done with the command that appears on that line. So that semicolon is a very important piece of syntax that we need for our code to run properly.